Ocean Worlds. Presented by Science at NASA. Earth, a world dominated by water. Trillions of gallons flow freely across the surface of our blue-green planet. While we once thought oceans made our planet unique, we're now coming to realize that ocean worlds are all around us. Our planet retains its atmosphere and, in turn, its abundance of liquid water, thanks in part to a very strong magnetic field, which provides protection from the solar wind. Without this magnetic field, our atmosphere would be stripped away, leaving the pale blue dot looking more like one of our neighbors. Scientists believe Venus's early oceans evaporated. With no water left on the surface, carbon dioxide built up in the atmosphere, leading to a runaway greenhouse effect that created present conditions. Likewise, Mars appears to have had oceans long ago, but the red planet's global magnetic field decayed, leaving it vulnerable to atmospheric erosion by the solar wind. Farther from the Sun, in the sub-freezing temperatures of the outer solar system, it may seem impossible for liquid water to exist. However, not only does it exist, but in some places, it may be more abundant than on Earth. Jupiter is orbited by at least 3 moons that contain oceans: Europa, Ganymede, and Callisto. Europa is crisscrossed by cracks and semi-rectangular features that look like ice rafts frozen into the surface. Below those immobile icebergs, researchers believe there is a vast ocean just below the icy crust, warmed by the tidal forces of Jupiter, containing about twice as much water as is found on Earth. In 2014 and 2016, the Hubble Space Telescope has observed what appear to be water vapor plumes coming out of the cracks near the South Pole. Photos of Ganymede from the Galileo space probe show ancient ice floes frozen into its surface. Moreover, Hubble has looked at Ganymede's auroras and seen signs suggesting an ocean's worth of salt water. Hiding beneath a thick crust of ice, the ocean on Ganymede could actually harbor as much as 4 times more water than all of Earth's oceans combined. Callisto also seems to contain a saltwater ocean beneath the icy crust, betraying its presence by the effects of Callisto on Jupiter's overlying magnetic field. In 2005, NASA's Cassini spacecraft found Saturn's moon Enceladus busily puffing plumes of water vapor and organic compounds out through fissures, now known as tiger stripes, in its frozen carapace. Cassini flew through the plumes frequently since then, and has discovered nanosilica grains and the presence of molecular hydrogen, both suggesting the movement of heated water on the seafloor of the icy moon. Other evidence provided by Cassini has convinced researchers that Enceladus has a global subsurface ocean spewing into space through these tiger stripes. Saturn's E-ring, the planet's second outermost ring, was actually formed from this water and ice. Saturn's largest moon, Titan, has a landscape dotted with lakes and seas. The liquid on Titan's surface is not, however, H2O. Researchers believe the fluid sculpting Titan's surface is a mixture mostly of methane with smaller amounts of ethane and other hard-to-freeze hydrocarbons. Other bodies around the solar system also show signs of liquid water. In 2014, scientists using the European Space Agency-led Herschel Space Observatory detected water vapor coming from 2 regions of the dwarf planet Ceres. NASA's Dawn probe reached Ceres in 2015, and while the water vapor had subsided, there were other signs of water. Ahuna Mons is an ice mountain apparently formed from repeated eruptions of salty, muddy water. Also, widely reported bright spots in Ceres' crater Akator are thought to be deposits of salt left behind by the escape and sublimation of briny water from below. Even distant Pluto may be an ocean world. As revealed by the recent flyby of New Horizons, Pluto's strangely molded surface features suggest the presence of a liquid underground. As astronomers look beyond our solar system, they are finding exoplanets of sizes and distances from their stars that could have oceans. And based on our solar system, these exoplanets could potentially have moons with oceans as well. The locations of water within the diverse environments of our own planetary system will guide and inform the search for oceans beyond our solar system. Next time you look out over the ocean, think about our neighboring worlds. They may have more in common with our own ocean world than we once believed was possible.